second-degree polynomials and finding their intercepts. Here's a second-degree polynomial. The first strategy we're going to try is just the same that you would try for any new function if you're not sure what it's going to look like. Just plug in some numbers. So I thought I would try the integers between -3 and 3. I'm going to work out plugging in the first number and then fill in the rest because I know that you know how to do this. Just remember to follow the order of operations. So if x is -3, we get 2 times -3 squared plus 4 times -3 plus 5. Just simplify. -3 squared is 9. 9 times 2 is 18 plus or minus, in this case, 12 plus 5. And then just go from left to right. So we have 6 plus 5 is 11. That's pretty big. Now just follow that same procedure to plug in all the rest. Okay, some of these turned out really big. So I'm just going to start by plotting the ones that are the most convenient. And we have so many points here, we can probably disregard some of the larger ones or choose new numbers to plug in that are better. So I'm going to start right here. -1, 3 is right here. And then 0, 5, and -2, 5. And we're getting a pretty good picture of what's going on here. Let's see, at -3, 5, 6, 7, 8, 9, 10, 11 is probably right about here. And then also at +1, we have 11. Okay, this is going to be a parabola, so it's a curve. Anything that's squared or larger exponent-wise is going to be curved, not angular, so don't put any corners. And just do your best to sketch a curve. Can't really use a ruler to help you out, and on paper it's easier to make that a little smoother. It should look more like a U shape than pointy. Now, where are the intercepts? Where is it crossing the x and y axis? Here's 1, so the y-intercept was right here. Notice the 0. That's how you can tell it's an intercept in the table, is when you see a 0. There's no point with a 0 y-coordinate because this graph doesn't cross the x-axis. There are no x-intercepts for this equation. Here's another example. This time let's start by finding the intercepts. So think about when x is 0 and when y is 0. So when x is 0, you can use the fingertip method to just cover up the x, and you'll see that what's left is y equals -4. So we have a point at 0, -4. Now, what happens when y is 0? That's a little more complicated because we're solving a second-degree equation now. Remember, if there's only an x squared term and no other variables, just get it by itself and take the square root. So I'm going to add 4 to both sides and then take the square root. Remember the plus or minus, and I'm going to switch the order around. X is equal to plus or minus 2. That means there are 2 x-intercepts. There is one at 2, 0 and also at -2, 0. Those are 2 different points, so write them down that way. Now let's graph what we've got so far. So 0 down 4 and then 2, 0, -2, 0. I think I will next plot 3 and -3 so we can just get a little bit more width here. So if 3 was x, I would get 9 minus 4, that's 5, and -3 turns out exactly the same way. So let's plot those. And now we're getting a pretty good glimpse of this. Remember, it's a curve. Try to make it look like a U, but narrow. A narrow U at the bottom, not a corner. And it gets wider and wider and wider as it goes up, just gradually. It's hard to make both sides look the same, and try to go right through that line if you can. Or try to go right through that point if you can. So there's my graph. Let's try to find those intercepts. So when x is 0, everything falls off and it's just 0. Now when you get 0, 0 for an intercept, that is both an x-intercept and a y-intercept. But sometimes that's not the only x-intercept. So I'm just going to take a minute to plug in 0 for y to make sure that there's only one solution here. I get 0 equals x squared, so really there is only one solution because plus or minus doesn't change 0. So all we know is that there's a point at 0, 0. We do not know that that's the center or anything else significant. So we need to plug in some more points. Let's go ahead and plug in some numbers on both sides of that and see what happens. When x is -1 and you square it, it becomes 1 times -3. and the same thing happens with positive 1. So this is looking pretty symmetric. If I go over 1, I go down 3. Same with negative 1. And if I try 2 and negative 2, 2 squared is 4, so that makes negative 12. Same here. And that's getting a little harder to graph. So I'm just going to stop there and go ahead and draw the curve. There we go. Let's try another. Okay, so let's start by looking for the intercepts. If we use fingertip method to make x 0, you cover up all the terms. X squared is 0, negative 3x is 0, so both of those are gone. The only thing left is negative 10. And then let y be 0, but write that one down because there are probably going to be 2 solutions for this. Now, when we have x squared and x to the 1, remember you cannot use square root to solve this. You've got to factor. If we look for factors of 10, we want it to be a negative 10, so we know that one factor has to be negative and the other positive. We want those to add up to negative 3, so it's got to be the bigger numbers that are negative, and this is the pair that adds up to negative 3. So we have 2x and negative 5x. If you look at the factors this way and this way, we get common factor of x here and 2 here, common factors of x and negative 5 over here. So this is x plus 2, x minus 5. Using our zero product property, we set each of those equal to 0. If x plus 2 is 0, then x must be equal to negative 2. So that is one of the x-intercepts. And if x minus 5 equals 0, then x must be equal to 5. So that's the other x-intercept. Let's see if we can graph those. Now, negative 2 is pretty big, so I think I'll use a scale factor of 2. Make sure you always mark that on your graph if you're going to change the scale. It's important to let everybody know what one box means. So 0, negative 10 would be here. 2, 4, 6, 8, 10. And then we have intercepts at negative 2, positive 5. I can't really tell where the lowest point of the parabola is because that's off center. So the best thing to do is to pick something between those x-intercepts and sort of hone in on it. So from negative 2, I've already got, let's see, we've already got 0. Let's plug in positive 2 and positive 4 and see if we can figure some more stuff out here. So at positive 2, I would get 2 squared minus 6 minus 10. So 4 minus 6 is negative 2, minus 10 is negative 12. And when you plug in 4, you get negative 6. So now it's on its way back up again. So the vertex is somewhere around 2, negative 12. It's actually halfway between these. So if you take these two x-coordinates and average them, you can find out what's between them, what's halfway. 5 minus 2 is 3, divided by 2 is 1.5. So we're not really finding the lowest point, but we are close. 1.5 would be right there. So it's just slightly lower. So there's a point right about there that's a little lower. And that's the parabola. So now let's draw in a curve that connects all of those. Remember, it's going to get wider and wider forever. There it is. So to find the intercepts, you want to plug in some zeros. There may be 2 solutions for the x-intercept, but not always. So use all of these different techniques, and when in doubt, just plug in more numbers to get more points, and remember to connect these with a smooth curve if you can. So second-degree equations make parabolas.